So, hey guys, happy Thursday. We're gonna do chapter 3 this week, lesson 3, for Stat 100. If you haven't already put your Penn State email into the chat box, you can go ahead and do that for me. We just use it for attendance purposes. So we're giving 3 sessions. So if you guys can go ahead and do that, that's awesome. Yeah, so like I said, we're gonna start off with lesson 3. So this is talking about good sample surveys, basically how we can go about making these studies good and representative, and basically something that we would be able to use. Okay, so let's get started. And you guys can stop me at any time. If you have any questions, obviously, feel free to stop me. And so I'll just go and review this stuff, and then we will do some practice problems at the end. And obviously leave room for any other questions you may have after that. All right, so first things first, let's just discuss like the difference between a census and a sample survey. So a census is going to be where we're talking about every single person in a population. So if you think about like the U.S. Census, that's what this is going to be. It'd be everyone in the United States. They're taking, technically it is a survey. They're asking every single person in that population a question. And obviously it's more difficult because it's hard to get information from everybody. It's easier to get it from a smaller group, so that's why we usually do sample surveys. And it'll give us the same amount of information, the same type of information if we do it correctly. It's a subset of our population, and the researcher they choose it. And it's still an observational study because it is a survey. We're not actually like imposing a treatment on them, but we are choosing that subset, and then we're going on to find information about that. So that's where that comes from. That's just to compare the two. Okay, so yeah, going on a little bit more to like talk more about sample surveys. So these are like different parts of a sample survey. So first we have our sampling unit. That's just going to be the individual thing. It could be a person, animal, whatever thing we're looking at, and that's the actual thing that we're taking the measurement from. So if we had like dogs and we're measuring like the length of their tails, the sampling unit would be the dogs themselves because we're taking information from them. Our population is just going to be our entire group. So this goes back to the fact that if you were to take a survey of everyone, our population would be the entire group, but this is important for sample surveys because we get that sample from the entire population. So we take a sample from this population, which is our entire group. And then parameter that I have there, that's basically all that is the actual measurement of a population. And same thing with, it says sample statistics there at the bottom. Statistics are the measurement of samples, and then parameters are measurements of populations. So like the numerical characteristic of a population would be a parameter. And then same with samples, the numerical measurement of a sample would be a statistic. So that's where that comes from. I skipped ahead a little bit there, but then just our sampling frame is just going to be the list of our sampling units that we actually use to that we contact, and then we get the sample from there. So it's not as big. If we were to draw this out, let me draw this. So we have like our entire population, for example. Let's just say this is our population. And then this within it could be our sampling frame. And then, so it's between the population and then the sample itself. So then this would be our sample. So if we're looking at it, so our sampling frame is, it's going to be all the sampling units that could be contacted for the sample, but then the sample is going to be actually like what the actual individuals that provide the data. So that's the difference there. The frame, you're not going to take all the people from the frame. They're just like the ones who it's possible to be taken from. It's possible that the individuals in your sample can come from your sampling frame, but not all of them do. So yeah, that's an example of that. All right. Okay, so the margin of error, this is something in statistics that basically kind of gives us an idea of like how well do we think we're doing. So remember, reliability is just talking about consistency. It's just another term for it. Reliability, another word for consistency. So so basically, if you're using a certain kind of instrument for a test and the results of the subjects that you're testing is the same the first and the second and the third and the fourth try, that's going to say that it's reliable. Because, you know, if you think about it too, like if so you say someone's reliable, it means they're going to be there, you know, no matter what, they're going to do the same thing every time. So that's where that word comes from, and that's what our margin of error is measuring. The inverse relationship with sample size, all that means is that like as our margin of error goes up, this is margin of error that I just abbreviated there. As this goes up, then our sample size would be down. So technically it'd be like, you know, if you decrease your sample size, your margin of error would go up. Because if you think about it, you always want to have a large sample size. So if your sample size decreases, that means you have more chance of getting an error. So lower sample size, higher margin of error. And then this equation down here is basically showing you that concept, except, you know, in an equation. So yeah, and then the actual like interpretation of the margin of error, like written out, would be that it's the difference between your sample percent, so what you get from the sample, and the true population percent, so what is actually true. And then, so the difference between those two will be within the margin of error at least 95% of the time. So that's like a lot of layers. So just make sure you're thinking of it that you have, at that point, you're comparing your true population percent, and then your sample percent. And it's saying that the difference between those two is going to be within the margin of error. So whatever number you get here, at least 95% of the time. So make sure you don't get that 95% mixed up with like the actual values of the percents for margin of error. You want to, that's just like the end part. So keep the different values. Those aren't going to be static. The 95% at the end of that definition will be static, but the other ones are going to change a little bit there. So that's where that comes from. Okay. So we have a few different types of sampling methods. So our first type of sampling method would be probability sampling. So basically, this is when the sample has a known probability of being selected. So, you know, a fair coin toss, you know, that's something like 50% chance each time. You know, there's a static probability each time that you sample something to know what it's going to be. And then non-probability, that just means that we don't know the probability of it being sampled. And these are things that if you did a sample like a convenience sample, voluntary response surveys, anything that you aren't like necessarily deciding, you know, this is going to be the probability for this and whatnot. If it's something that it's kind of out of your hands, that would be non-probability sampling in that case. Okay. All right, so probability sampling methods. So I won't go too far deep into all these because obviously you read them in your notes, but I will hit on stratified and cluster sampling because those are usually the two that students find the most difficult to wrap their head around. I still have to go over them a little bit myself, you know, so definitely something to be thinking about just to make sure you understand the difference between them. So if we're talking about stratified sampling, first what you would do is you're taking your population and you're putting it into different groups that are based on like a factor that can influence the variable. So you're kind of trying to cancel out any type of like confounding variable. In that case, you want to make sure that you're splitting the groups up into something that may have messed with the data if they stay together. So for example, if you were looking at countries and you wanted to take a sample from each, you wouldn't want to take a sample of 100 people from each because 100 people in the United States may not seem like a lot, but maybe there's a country that only has 100 people in it. So in that case, you might want to do something like taking like 10% from each. So then you're taking the same amount in terms of the country itself, so that's not going to affect your data in that way. But you still want to make sure it's random. We always want to have random samples. And then, so it's basically the whole point of Stratified is it's taking groups that are different and then making them more similar. So let me draw that. So yeah, we're taking different groups. And then the goal is, by stratifying them, we're trying to make them more similar. Okay, so you're dividing it into homogeneous strata, so that means the same. And then you're going to take a simple random sample from each of those strata. And then you're going to combine all those samples at the end. So after, let me choose a new color. So after you get these similar groups, you're going to take a simple random sample from all these groups that were similar. And then you want to combine all of these together to create your end sample. So basically, to review that, you're going to have a bunch of different groups starting up here. And what we want to do is make a bunch of groups that are similar from these different groups. These are going to be similar groups. And then from each of these groups, you're going to take a simple random sample because you don't want to use the entire group. So you take simple random samples and then take all those simple random samples that you just took, and then that'll be your end sample that you use for stratified sampling, okay? And then the main difference then for cluster sampling, you're still dividing it into groups initially, but the groups are going to be heterogeneous. They're going to be different from one another so that you can use that entire cluster as your unit. You don't have to go through and then re-add them all together. So for cluster sampling, let me draw this out. For cluster sampling, so you're first going to divide into heterogeneous clusters. So these are going to be different groups that we have, and they're all going to be different. I guess I can make them going to be heterogeneous. And then we want to take a simple random sample from all of these. And then we can use these simple random samples because they're already taken from heterogeneous groups. So in that case, we're able to use that entire sample. So the main difference is that analysis is done within each strata for stratified sampling. So this is what we're talking about here, each strata, because these are strata that we created here, similar groups. So for stratified sampling, analysis is done within each of them. And then for cluster sampling, the analysis is done with the entire cluster as a sampling unit to decide that. So in that case, that's like the main difference between the two. So cluster, you're going from different to similar, or they're already going to be like different. So then you can, when you take your samples, you don't have to make them similar first. And then for stratified, you want to make sure that you make them similar first before you do any of that. So yeah, okay. Okay. Non-probability sampling. So this is basically when we're just talking about, these are like the easy way out type thing, like volunteer samples. I mean, we do use them. They're not bad, but these are like examples of like where things can go wrong because we don't have random like stuff going on. We're just, these are volunteer samples, convenience samples. So these are going to be off of human choice. The researcher's not deciding who's going to respond to them. It's just kind of, convenient samples could be, we talked about these, if you just kind of ask who's in your immediate area, that would be a convenient sample, and it's not going to be representative of the entire population, that kind of thing. High chance of bias here, depending on who responds, maybe you can have, for volunteer samples, maybe, only people responding are the ones who are really passionate about that subject, so that's not going to be representative. And then, we compare to observational studies because you're not doing anything. The researcher isn't imposing any sort of treatment on that to change it. So. All right. So one last thing, we'll just talk really quickly about different types of variables. So our explanatory variable and our response variable are going to be the two different types of variables we use whenever we're doing an experiment. So our explanatory variable explains our response, okay? So just think about it. Your response is going to be like if someone's talking to you, your response is what you say. So what you said was dependent upon what the person initially said to you. So that's why that's a response variable. Explanatory is going to explain. So think of the explanatory variable as the first person talking. So the person talking is influencing your response. So your response is dependent on who is talking. So yeah, explanatory variables are going to be independent. They're predicting the outcome. Nothing affects them. And then your response is dependent. And specifically, it's dependent upon the explanatory variables. That's where that comes from. And remember what confounding variables are. These are important in this case. So a variable that is related to your study, but it's not necessarily something that you want to be like observing or looking at. So this is mostly a problem in observational studies, like we were just talking about in the last slide. But in order to control for this, we always want to just randomize our data, and that'll kind of give us different levels to the experiment. It'll make more sense. Make sure you don't have those confounding variables there. And treatment I just have there because usually if you're doing a randomized experiment, you're going to have some sort of treatment. Experiments always have the researcher imposing some sort of treatment. So that's where that comes from. All right, cool. Let's do some review questions. So you haven't done this. If you haven't done this before, we'll just go ahead and read the question. You can look over the answers and let me know what you think, and then we will go over it together. So this first one says, in a survey of n equals 400 randomly selected Americans, a polling organization asked, do you favor eliminating Saturday mail delivery to lower the price of a postal stamp? In the sample, 54% answered yes, and the margin of error was reported to be plus or minus 5%. Which statement about the margin of error is correct? So go ahead and look over these, let me know what you think, and we'll go over it together then. Okay, good. So let's go over this one. So let me just go back to this slide. Actually, I won't go back to it, but I will just write this out. So remember, our interpretation of our margin of error, if I were to just write this at the top here, so it's going to be the difference between the sample percent and the true population percent. Hopefully you can read my handwriting. True population percent will be within the margin of error at least 95% of the time. Okay. So this is our definition, or like in our interpretation of the margin of error. So basically, we want to look through these. So basically, we found that our margin of error was plus or minus 5. So this is going to be our margin of error. So we are, in this case, so the difference between the sample percent and the true population percent will be within, technically in this case, 5%, at least 95% of the time. So if we were to go through these questions here, let me see. I'm silly. Can you still see my slide? Okay, it looks like it's still working. Okay. All All right, so we have, so what we want to do here is look and try to decide between, so, you know, there's a 95% chance, there's a 95% chance, so they all start with that. And let's look at these all start with in the sample and population. So the first difference that we see here is proportion or percentages. So we kind of have to decide which one is going to make the most sense. So we can immediately cross out, the exactly, yeah, we can cross out C because it says differ by exactly 5%, which is not true. So because we're saying within that, so this exactly wouldn't make sense. B is saying something about this population proportion being 54%. That's not what the margin of error is telling us. It's not talking about the chance, so that's not true. And then A is saying that it's more than 5%, but our margin of error is saying that it's within that, so it wouldn't be A. So our answer has to be D, because the sample or the population percent will differ by less than or equal to the margin of error in 95% of the sample. So we do have this 95% chance that our sample and population proportions differ, but it's always saying, so it's saying within the margin of error. So that means that, like, the margin of error or less, it has to be within it, you know, plus or minus 5. So differ by less than 5%. So the sample percent and the population percent will differ by less than or equal to the margin of error, not in 95% of the samples. So that's where that 95% chance comes at. So our answer would be D there. Does that make sense? Okay, cool. Okay, yay. I know everyone's always just like, well, now it makes sense. Why didn't you just say so? But sometimes you just got to talk through it. Okay, great. Let's see. We have a few more. All right, so a national poll wants to determine what percent of all Americans favor a change in delivery to reduce the cost of postal stamps. A random sample of 1,000 Pennsylvania was obtained from a list of all Pennsylvanians. What is the major problem with this survey? So go ahead and look at this one and let me know what you think. Okay, great job. Yep, so our answer here would be A. So if we kind of go through these, like D is not correct, failed to obtain a complete census. You don't have to do a census to get a survey. That just doesn't make sense. C, it's not a convenient sample. We can obviously, actually, we can just cross out both B and C, because these would be if we, like, if you did randomization, like volunteer and convenient samples aren't true. So that, and it says here that they took a random sample. So that would be true. So yeah, A would be the correct one. They just, basically, they did use the wrong sampling frame. They're trying to find out about all Americans, and they only asked Pennsylvanians, so it's not really giving a representative sample. So good job. Perfect. All right. A researcher wants to estimate the proportion of Americans that favor a change in delivery to reduce the cost of postal stamps. He randomly picks 10 Americans from each one of 50 states for a total sample size of n equals 500. What type of sample is this? So go ahead and check this one out. Okay, great, perfect. Yep, so this answer is A. Great job. People usually don't get this one right, so you guys are doing great. So in this case, if we think about it, each state is going to be our strata, and then the 10 Americans randomly selected from each state is going to be that random sample that we had. So, we had our 50 states. Let's just make it, if these were, let's just act like these are our states, okay? If we're just for an example. And then they took 10 Americans from each of these. And then after they took this times, there was 50 of these states. So then altogether, they got the sample size of n equals 500. So these were our strata up here. And then that's where we took the samples from that. So that would be stratified. So good job. Perfect. Okay. Okay. Researcher wants to estimate the proportion of Americans that favor a change in delivery to reduce cost of postal stamps. Suppose he randomly selects 25 counties across America and asks each person living in the selected counties to fill out a survey. What type of sampling plan was used here? So it's a similar question, but let me know what you think. All right, cool. So, so if we look at it this way, so each county that they chose is going to be a cluster because the county that they chose is already heterogeneous, okay? Because the 25 counties are already randomly selected, so those are already going to be random. So since remember in the cluster they're already randomized, you can use that entire cluster. So then each person within that county is measured. So each person within the cluster, because they're able to do that because they're already randomized. They don't have to re-randomize them again from each sample. Because they randomly selected those counties, and then the counties were already randomized. They didn't have to do anything else. So that would end up being a cluster sample there. So it'd be C. Does that make sense? No. All right, so let's look at it. Okay, so let's say, so our entire thing is going to be America. That's like our population. And so remember when we were taking strata, that was making a bunch of different strata that were the same. So when you take strata, they're all going to be the same in each group. So that's why you have to take a certain amount, like the last one we had to take 10 out of this group, 10 out of this group, 10 out of this group, and then combine those. Because from each strata, those are all homogeneous. There's the same people in this one, same people all together in this one, and all together in this one. But in this case, they selected 25 counties. So each county is already heterogeneous. Like each county doesn't have the same people in it. So it's already a heterogeneous county, so they can take a sample from everyone in that county. They don't have to take another sample to randomize it and make it. They don't have to take a simple random sample from something that's already random, because it's already, each county is already random, so they don't have to like do that again. Does that make sense? Maybe. Okay. Okay, cool. And let me know if it doesn't. Like seriously, don't let me move on if it doesn't. But okay. All right. All right. Which of the following is a research strategy that limits the researcher manipulating the participants' environment in some way? So check this one out. Okay, so let's look at this one. So If we're limiting the manipulation, basically and these are a list of the different strategies, and to limit the researcher and manipulating the participants, the answer to this one's going to be C, because the rest of them, so margin of error, it comes from a randomized experiment. Randomized experiments, remember, is when we're imposing some sort of treatment. So we are going to be manipulating. So B, the researcher isn't being limited in this case. And margin of error, it's not necessarily a strategy, it's just something that happens after you do manipulation. So that's where that comes from. So it wouldn't be all of the above either, obviously, because B and A are not correct. So observational study, remember, is the one that we don't impose any sort of treatment on it, so the researcher is unable to manipulate anything. Does that make sense? All right, cool, perfect. All right, good job tonight, guys. So yeah, you can go ahead and obviously watch this and the other reviews back on the YouTube channel. Our next review will be for lesson 4 next week, next Thursday at 8:30. As always, if you have any other questions, go ahead and type them in the chat box. If you haven't already given me your Penn State email, that would be great. And if not, you guys are good for tonight then. Yeah, if you could type it in the chat box, that would be awesome. Thank you. Yeah, go ahead. What's your question? You mean like why can't you do like, I mean, systematic, you're going to be taking like every like 1, 2, 3, like every like, 10, every that kind of thing. Like if you just start at 1, it would just be a simple random sample. Do you know what I mean? Like systematic it means that you're taking it like you're taking every nth number. So like every 10, you would take a sample from, every 20, that kind of thing. So yeah, if you started at 1, it would just end up being a simple random sample basically, because you're taking every sample then. Does that make sense? Yeah, so you can do that too. You can start at like, because the main point is if you start at 1, like it's not going to be it's not going to be any different than taking a normal sample. So if you choose a random starting point, then it can be systematic, because then you can choose any certain amount. Like you can start anywhere and then move up like in any way. But that's a good question. I understand what you're asking. Yeah, sure. You would go from, usually you would start at like 10, because you'd want to do every 10th, so the first one would be the 10th, I don't have access to the book, but I could ask for it if you needed me to have access to it. Okay. It's just a researcher's decision. He or she probably had, um, a reason for that. I understand what you're saying, but then again, if it was 2 to 2, then it's kind of just the same as doing like 1. So if it's 3 to 2, that's going to give some variability in there. So it's just dependent on the researcher. That should be in the next one, I believe. Chapter 4. Yeah, because this is lesson 3. So yeah, let me know if you have any more questions. Okay, sounds great. Have a great night.